x by 1. So x is now going from 0 to 1. And then we go, where do we go now? We are at the end of a loop. We go back to line 3. Very good. We're going back to line 3 because this end while is ending the while that is starting on line 3. And that's why we're going back to line 3. So when we're dealing with nesting of statements, we have to keep track of all this stuff here. Which while am I ending? Which repeat until am I ending? Which if am I ending? And then perform the operation accordingly. So now we're back to line 3. We ask the question, x is less than 3 is true, because x is only 1. 1 is less than 3 is true. And then we have to go to line 4 again and repeat that whole thing, right? That's a chore. So instead of doing that, I'm going to do something like this. Copy, paste. Okay. Now, when I paste, these numbers are not exactly correct because this number is wrong. Because on line 7, this should be the current value of the sum plus the current value of x plus the current value of y. So that's why it is wrong, but you can see that as soon as I update this one, this guy is updated automatically because this one is calling for the right places. You can see from the formula here, this 7 is the result of C19, which is this guy, plus, okay, I think I can double click it and use color coding, and that shows a little bit better. It's color coded. C19 is the blue one, D13 is the red one, and then E21 is the kind of purplish one. Okay, so this way,
it's missing the 1.
Oh, it's missing the 1. Oh, all right. So we have to change that one to 14 because they're off by 1 at this point. Okay, so now I think they should be right. Yep. Okay. Very good. And whoops. So now we're back to line 9. Line 9 is adding 1 to x, but that one is also incorrect here. So instead of saying 1 here, I can say it is this value plus 1. Okay. Now you don't have to do it this way. You can always just kind of do it line by line, but it should come to the same conclusion. Are we doing okay so far? So we're back to line 9, and when line 9 is finished, it has to go back to line 3. And line 3 is still true, or the condition of line 3 is still true because 2, which is the current value of x, is less than 3. Yep.
Well, you said these loops will get bigger and bigger. Eventually, when we move on to the next class, will the while end loops be color coded so we know? So that we know if it's
No.
one another, or just we just have to intuitively know and see it organized properly?
You have to use the indentation to tell you which one is ending. Now this is one cool trick though. Okay, let me just do that one more time so that you guys can see how I did it. Now at this point, okay, my trace is all the way down here. Okay, it's a little bit difficult for me to see what is column C, what is column D, and what is column E because I cannot see the labels of those columns anymore. So one trick you can do is to go to this loop, this place here. When your cursor turns into up-down arrow, you can drag that bar down a little bit. What it does is it is splitting your spreadsheet into 2 halves in this case. The top one has its own scroll bar, the bottom part has its own scroll bar. So they're still on the same columns, but they now can be scrolled separately. So this makes it easy for me to see the labeling of the column while I'm still working on the trace itself. Is that okay? So this way, I can actually go all the way down here. It makes it very easy for me to tell which column is which variable. All right. So now that we are back to here, instead of doing all the calculations myself, I'm going to go to this part here, this part here, and then do another copy and paste. And this time, everything will be right because you can see that this is adding up the 3 values correctly, and this one is also adding up the 3 values correctly because the relative locations are the same, so that's why this approach here works. After line 9, I go back to line 3. This time when I ask the question, is x less than 3 true or false? It is finally false because 3 is not less than 3. And where do I go next?
Post.
So we go to post, and we're all done. Okay? Now, I don't recommend using this trick to finish this assignment when you're doing it on your own, because I want you to practice doing this by hand, just so that you know when I encounter an end while, which while am I ending and where do I go next. Okay? But this is the solution. This is the answer, the solution to the entire problem. My notes contains a part of the solution, but it did not finish the whole thing. This is the entire thing. Do we have any questions about this part of the pseudocode? About nesting? No questions about nesting at this point? Okay. All right. So let me make sure that I save this solution. And we can go back to the notes. Now, if you like, a pictorial representation of the algorithm, this is what it looks like, if I turn that algorithm into, a picture. But what you can see here is this dotted line here is representing the outer loop, which is from line 3 to line 9. This dotted line here is representing the inner loop, which is from line, cannot remember, line 5 to line 8. Okay, so you can see one loop is completely contained within the other loop. And then before the inner loop, we have one initialization statement, and then after the loop, we also have one increment of x. So those two statements are not inside the inner loop, this statement here, and this statement here. They are not inside the inner loop, but they are inside the outer loop. Do we have any questions about this? Nope. This is all okay? All right. And this is the partial trace that I was talking about earlier. And this is really just repeating what we talked about already as I went through the loop. And we are done. I mean, this is all there is to it with nested statements. Now, before we go forward and talk about something else, let me give you another example of a nested structure, but this time it's not a loop. This time it is conditional statements. So we'll go ahead and start a new document. Close the other one because I don't need that anymore. And I'll save the document first as max3. Okay, we're finding the maximum of 3 variables, but this time we'll do it in another way. All right, so let's go ahead and try to write this code. All right, so this time what we'll do is we'll use nested conditional statements to do exactly the same thing that we did earlier, which is using the conjunction within a line. So I'll say if w, so we are given 3 variables, w, x, and y, the same thing, and we want to find the maximum and then put the maximum into z, which is something that we have done already, but this time I'm changing the structure of the program a little bit. So the first one, we just compare w versus x, okay? And it will do something at this point, else we'll do something else, and then we have end if here. This is actually how I write my programs. Okay, when I write my programs, when I write a conditional statement, I will finish up the condition, I will put in the else, and I will also mark the end of the entire conditional statement, and then I go back and insert the content into it. The reason why I do it this way is because this way I will not forget where to end a statement. When you do this in C, the syntax is a little bit different. I'll just show you what it looks like in C. But I personally find this approach to be very useful, so I'm hoping that some of you may find it useful too. In C, a statement looks more like this. This is the actual C syntax to do the same thing. So if w is greater than or equal to y, there's no word then in C and C++, but I use curly braces to indicate the beginning and the end of the then branch, and then I'll use else, and then use open and close curly braces to indicate the end of the else branch. And then I'll go back and fill in, okay, let's see what I'm supposed to do when w is greater than or equal to y is true. So this is the way I write my code. Okay, I'm just using this as an example, but I do the same thing with while loops, for loops, and all the other structures that can be nested. If I do it this way, I will never ever forget to close a curly brace or have to figure out where I'm supposed to close the curly brace, because the indentations will always be right if I do it this way. Okay, so it's a trick that I picked up, that I find really useful for myself. Whether you find it useful or not is entirely up to you when you go to the C and C++ class. All right, so let's go back to here and ask several questions. So in this case, it's a little bit more complicated because inserting rows is not the same thing as opening new lines. All right, so let's think about at this point what we are supposed to do. We do the indentation first, so we automatically have indentation when we're here. If W is greater than or equal to X, that means X is not going to be the maximum. Okay, W is a potential. Okay, it's a potential candidate for the maximum. So now it's between W and Y, right? Because I can just rule out and say, okay, we can just not consider X as a potential maximum. It's between W and Y. So that means the next comparison I have to do here is to compare W versus Y. Okay? So once again, what if W is less than Y? And if here. All right, so we'll go ahead and insert a row here. All right, at this point, what do we know about the relationship between W, X, and Y? W is greater than or equal to X, and W is greater than or equal to Y. We know that both conditions have to be true in order for us to get here. Is that okay? Does everybody understand why both conditions have to be true when we get here? Okay. So when both conditions are true, well, that means W is certainly the maximum of the three. Now, it is possible that X, Y are exactly the same as W. It's entirely possible because the comparisons were I only used greater than or equal to for comparisons. But it doesn't matter because if W, X, and Y are all the same, that means W is still the maximum of the three. It's not a unique maximum, but it is still a maximum of the three. So at this point, I can say Z gets W. It'll be perfectly fine to do that. The next question is, what do I do over here? What do you think? At this point, I know W is greater than or equal to X, because otherwise I would not be in this nested conditional statement. But I also know that W is greater than or equal to Y is false, which means W is less than Y. All right, so we have established the fact that X cannot be the maximum, but because W is less than Y at this point, we also know that W cannot be the maximum. So that only leaves us with what? Y, exactly. So at this point we can say Z gets Y, because at this point we can confirm that Y is the maximum. Yep, go ahead.
Is there a reason why you didn't put a then in the if W is greater than or equal? Oh.
I just made a mistake. That's one thing that's good about pseudocode is, I don't have to deal with the compiler. So, unless you guys tell me that I'm missing something, nobody knows. The other question is, if I did miss a then, would it change the way you interpret the pseudocode? No, because people are not as strict when it comes to these keywords or the placement of the keywords. Yep.
I'm wondering why did you have to